Good day. I'm John Kitty Gamboa from BSRT 2B, and today I will discuss or explain chapter 4. This chapter on electricity, magnetism, and electromagnetism briefly introduces the basic concepts needed for further study of the X-ray imaging system and its various components. Because the primary function of the X-ray imaging system is to convert electric energy into electromagnetic energy, X-rays, the study of electricity, magnetism, and electromagnetism is particularly important. This chapter begins by introducing some examples of familiar devices that convert electricity into other forms of energy. Electrostatics is the science of stationary electric charges. Electrodynamics is the science of electric charges in motion. Electromagnetism describes how electrons are given electric potential energy, voltage, and how electrons in motion create magnetism. Magnetism has become increasingly important in diagnostic imaging with the application of magnetic resonance imaging (MRI). This chapter describes the nature of magnetism by discussing the laws that govern magnetic fields. These laws are similar to those that govern electric fields. Knowing them is essential to understanding the function of several components of the X-ray imaging system. Electromagnetic induction is a means of transferring electric potential energy from one position to another, as in a transformer. Electricity is a set of physical phenomena associated with the presence and motion of matter with an electrical charge. Both electricity and magnetism are related to the phenomenon of electromagnetism. Electricity is at the heart of many modern technologies, being used for electric power, where electric current is used to power equipment, electronics, which deals with electrical circuits involving active electrical components such as vacuum tubes, transistors, diodes, and integrated circuits, as well as associated passive interconnection technologies. An electric field is created by the presence of an electric charge, which can be positive or negative. The movement of electric charges results in an electrical current and magnetic field. Electric charge comes in discrete units that are positive or negative. Electrons and protons are the smallest units of electrical charge. The electron has 1 unit of negative charge, while the proton has 1 unit of positive charge. Thus, the electric charges associated with an electron and a proton have the same magnitude but opposite signs. Magnetism is a set of physical properties mediated by magnetic fields. Electric currents and elementary particle magnetic moments combine to form a magnetic field, which acts on the other currents and magnetic moments. Magnetism can be found in all substances. The bulk susceptibility of magnetic materials is classified. The magnetic state or magnetic phase of a material is affected by temperature, pressure, and the magnetic field applied. As these variables change, a material may exhibit more than one type of magnetism. Magnetism is a component of the larger phenomenon of electromagnetism. Electromagnetism, or the electromagnetic force, one of the four fundamental forces of nature. It generates light and energy and holds atoms, matter, and the world as we know it together. Electromagnetism is a branch of physics that studies the interactions between electric and magnetic fields. All matter has an electric charge, which can be positive or negative or zero. Opposite charges attract while like charges repel. These electric forces bring and hold atoms together, and when the atoms gain a positive or negative charge through the transfer of electrons, a measurable electric field will form. If those electrically charged particles start to move, the field will become flowing electric current and form a magnetic field around it. Under the right circumstances, interacting electric and magnetic fields can continuously produce and sustain one another. This generates an electromagnetic field that transmits waves of electromagnetic energy of radiation into space. The intensity of this radiation is determined by its frequency. These frequencies makes up what's known as the electromagnetic spectrum. Near the middle of the spectrum is a visible light, such as the light emitted by stars, fireflies, and computer screens. On either side are invisible electromagnetic waves. On one end are low-frequency radio waves that broadcast television and radio signals. microwaves that carry telephone signals and cook food, and infrared waves emitted by fires. On the other are short high-frequency wavelengths, ultraviolet, X-ray, and gamma radiation. Unlike low-frequency waves, these waves can pass through the human body, making them useful for medical applications, while electromagnetism has daily applications. It's, al- it's also the engine that drives the planet as a whole. Thousands of miles below the Earth's surface, a layer of liquid metal turn and flow. This generates electric currents that then produce magnetic fields that altogether encompass the entire planet, called the geodynamo. This process causes Earth hold to attain positive and negative charges, turning the planet into a giant electromagnet. This phenomenon also creates a protective layer around the planet shields This phenomenon also creates a protective layer around the planet, shields us for the most harmful radiation in space, leaving us to enjoy a world held together by a strange and fundamental force of electromagnetism. Electro- Electromagnetism studies the electromagnetic force, which is a type of physical interaction between electrically charged particles. The electromagnetic force is carried by electromagnetic fields, which are elec- made up of electric and magnetic fields, and it is responsible for electromagnetic radiation such as light. It is one of nature's four fundamental interactions, commonly known as forces, along with the strong interaction, the weak interaction, and the gravitation. At high energy, the weak force and electromagnetic force combine to form a single electroweak force. The electromagnetic force, also known as the Lorentz force, is used to define electromagnetic phenomena, which include both electricity and magnetism as different manifestations of the same phenomenon. Electromagnetic forces are responsible for chemical bonds that form molecules as well as intermolecular forces. All chemical processes that result from interactions between electrons of neighboring atoms are governed by the electromagnetic force. Electromagnetism is widely used in modern technology, and electromagnetic theory serves as the foundation for electric power engineering, electronics, and digital technology. That's all. Thank you.